Hello everybody and welcome to the CCIE Routing and Switching version 5 written and lab exam. The idea behind this entire series is going to be taking a fundamental approach from the CCNP, which I just earned a couple of weeks ago, up to and through the CCIE level of understanding for the routing and switching track. Now, I myself have not even attempted the CCIE written yet. I am in the process of studying for it. But one of the things that I wanted to cover in this introductory video is an overview of what we're going to cover, so that at least you have a game plan as to the path that I'm going to take with the training and how I'm going to take care of the issues that you might run into with studies and the blah days where you're studying a topic you really don't want to deal with and things like that. And my path and my training methodologies and techniques that I've used over the past couple of years to take and pass exams and earn certifications to basically push myself through the networking industry up to and including a senior level network engineer position that I now have. So the idea behind all of these videos is to take what I call the learning the technologies way of doing things, where we take the technology step by step and build upon those. So assuming that everyone watching this video has a CCNA and CCNP level of understanding, you don't have to have the certification, you just have to have the understanding. So if you know what Ospf LSA type 3s are and how they work, then you're going to have a better understanding of how things are going to work once we get into more details about how, when you're working on the ABR and you're having an issue with summarized routes, and how the forwarding address can affect the way your traffic is routed and how summarized routes can be affected. So the premise behind the videos is going to be taking a fundamental approach to each technology. So we're going to walk up as if we just walked out of a Cisco exam, passed our CCNP T-sheet exam, and we've gotten the award letter from Cisco saying that we are now a CCNP, and our next goal is the CCIE routing and switching written exam. So we're going to take a fundamental approach. So a lot of what we're going to talk about is going to be theoretical out of the gate. We're going to go, and as we're going through each video and working through the technology and understanding the concept behind why a VLAN is a VLAN and why VTP is beneficial in some designs and not beneficial in others, we'll be able to take that fundamental understanding of what a VLAN is, what VTP is, how span tree works, all these different aspects, and then be able to bring them back and implement them and troubleshoot them and figure out why it's doing what it's doing based on a given design and a given set of configurations. That ultimately is the idea behind the CCIE. You are going to be given a very large topology, 10, 15, 20 routers possibly. With the V5 lab being all virtual now, it's pretty much sky's the limit as to how many devices you may or may not see. In the version 4 blueprint, a lot of the CCIEs that I know right now, when they took the exam, they were taking it on 5 routers and 4 switches. Internet Network Expert, IP Expert, who's another company out there, Narbic, I believe they were all between 6 and 8 routers, our main routers, and 2 to 3 backbones and 4 layer 3 switches. So you take that mindset of a version 4 labber, simply somebody that was using the version 4 blueprint and training materials to study for the V4 lab, and we're going to flip the script a little bit on it, and everything's virtual now. So theoretically and hypothetically, the CCIE lab exam could be 100 routers. Now I know Bruno, the project manager for the CCIE route switch program, has said that they won't have that many routers, but it's not out of the question to see 20, 25 routers, something similar in size to the troubleshooting section that you might see. Well, that you will see. It's there. It's not going away. Might as well get used to it. So the idea behind the way that I'm studying the material is to take a fundamental approach to each technology. So for me, I'm already pretty good at OSPF, EIGRP, RIP, BGP, okay with MPLS, I'm okay with quality of service, I'm okay with multicast, just at up to a CCNP level of implementation. So I could take 8, 10 routers, put them together, get some switches in there, get some routing going, and everything's good to go. But to be an expert, you have to be able to drill down and figure out, based on whatever's going on, how to figure out what's going on and be able to take it to the next step. I've walked into a couple of networks where I've had to step in through the door, first of all, and the first thing that you step into is it could be a mess. And the last network that I walked into it was 22 branch locations. It was more of a retail sales type of setup, to where you had one headquarters location, which was here in the area that I live in, and then you had 22 remote sales offices. And they all, there was a small company. I can't tell you who it is because that would conflict with the contract that I have with them. But the basic idea with this is they had VPNs set up between the branch office and the remote branch office, and going over the service provider cloud. So the idea behind it was to go in, and things weren't working correctly. They called me. The CEO was kind of upset. Things weren't working the way they were supposed to be. They had brought somebody in that claimed that he could do, was had more technical knowledge than God and some other things. So when I walked into it, it was already pretty much broke when I walked into it, and it took me a couple of weeks to figure out exactly what was broke and different ways to fix it. Because as you're going to learn pretty quickly, as we're going to go through the lab exam information and the written exam information, that when you're walking in, there's already more than likely going to be partial configuration already there. So respectfully, you might be walking into a partially configured network that you either have to take over and finish the configuration to get it where the task is asking you to, or they've implemented something incorrectly and you've got a route flap or potentially a routing loop, and you got to figure out where it's at. So these are all things that we're going to need to talk about in pretty extreme detail. So this is going to be a 20-30 video series where you've seen most of my video series that I put out. I try to keep between 20 and 30 videos so that I cover the technologies in enough detail to the level that you're going to be attempting the labs or the exams at. The CCIE totally takes that premise and limitation, if you will, away. You're walking into a potential exam size of 15 plus routers, maybe, or 15 plus devices, and it's a daunting task to go in there, and you've only got 8 hours. But the idea that we're going to cover is we're going to focus the majority of our time on core topics. What I mean by core topics is in the lab is going to be layer 2 and layer 3 technologies, which is going to be the majority of what you're going to see in the lab. And then anything additional, which is going to be an optimization potentially, or something that doesn't have to be there in order for something else to work. So you see infrastructure security and infrastructure services. To me, an infrastructure service is going to be like multicast, which is going to make transporting a video feed to specific users. You could do multiple feeds, but for every feed, if you have one feed, let's say it's a 700, or let's say it's 1 megabyte or 1 megabit per second that it's forwarding at. For every additional feed, that's additional megabit that it's going to chew up bandwidth-wise. So if you take that into effect, that's an optimization to send a single feed down to, in PIM sparse mode, a rendezvous point, and then you're going to have a bunch of hosts using Igmp use Igmp to join that that RP, which is the rendezvous point, and then PIM, protocol independent multicast. And part of the reason it's called protocol independent means it it relies on the underlying IGP to present a loop-free network, so that when you're forwarding video traffic from the source, could be a live webcast, it could be, it could be anything really, and it's able to forward that traffic a single feed down to the RP, and then the RP is able to replicate as many requesting receivers, that many transmissions as there are requesters for it. So if you only have 2 requesters for that video feed, you're only going to have two feeds going out from the RP. So you take that optimization, if you will, and you put it into infrastructure services. That's going to be a topic that we're going to cover later on once we've got core technologies. So core technologies is going to be your bread and butter. When you're in the lab, it does not matter, and this is coming from a CCIE that I personally know, it does not matter how good you know multicast. If your route redistribution, your BGP or MPLS routes are not there, or you cannot trace from point A to point B, then multicast, it doesn't matter how well you know it. It's not going to work, because your layer 2 and layer 3 technology implementation may not be right. So you take that aspect of it and you put it into a perspective of what you might actually have to deal with, and you kind of weigh what you're going to study. And I'm really happy that Cisco laid it out this way, because it gives me, the person that just passed my CCNP a couple weeks ago, that is now studying pretty hardcore for the CCIE written, at least I have a game plan as to what I need to study and how well I need to know it. So networking principles, and we're going to cover the written and lab exam topics here in just a moment. I just want to kind of go over the exam content, but the idea behind it is networking principles is going to be 10% of the lab. So you're going to need to know, or the written, I'm sorry, you're going to need to know how TCP works, how UDP works. It's going to be like almost like a network plus, advanced network plus really, concepts work. And then you're going to have layer 2 and layer 3 technologies. You better know what BPDU guard is. You better know what layer 2 forwarding equals. Be able to describe a layer 2 domain, a layer 3 domain, and how they work. And then obviously you got layer 3, which is going to be the core. There's going to be a lot more routing than there is going to be switching. And it's actually, I should say, bridging and switching, because you can do both. But the idea behind layer 3 is routing. I mean, that's the bread and butter of most engineers, is their routing skills. Vpn Technologies is going to be a big portion, because of the fact of they've taken, this is at least what I think what Cisco's done, they've taken information and topics covered in the CCNP for the route switch cert. When I took my route switch exam, or my route exam, there was VPN Technologies on there. Better believe it. And I can't tell you what questions I saw or what the answers were, but I can tell you that you better know what IPsec is and how it works. Not saying you have to know it to the extent of a CCNA security. Well, that wouldn't be such a bad idea. CCNA security, which actually is in another exam I'm studying for right now, which I figured it'd be easy. I actually spent just a week studying for it, and I have it in a couple days. So I'm looking really forward to taking that, because that's going to be able to, that's going to bridge the gap for these two right here. So infrastructure security and VPN technologies, it actually goes a little bit more in detail the CCNA security than it does in the actual CCIE lab, but the idea is to have an underlying understanding of how everything works. So now I know how Cisco iOS IPS works. Now I know how zone-based firewall works. I know how to implement it. I know how to configure it. I know how to troubleshoot it. And that right there is a big bonus to me. I know how IPsec site-to-site VPNs are supposed to work. I configure them both through the GUI, the Cisco Configuration Professional, and through the command line. So that right there is going to be a bonus to me long term. So the idea behind what you're going to see in the written is, and like I said, I'm really happy Cisco broke it down like this. So now you're not thinking to yourself, okay, I need to be an expert in this. You just basically have to know what it is. So the idea behind what we're going to cover, it's not too excruciating in my opinion. and they cover what they expect you to need to know. So networking principles, these are going to be foundation topics, and now it says an expert level knowledge of these essential topics. So when we get to the written exam here in just a moment, I have the tab up there ready to go. I just want to cover this real quick. Layer 2 technologies, predominantly LAN and WAN. So that means you're going to be dealing with layer 2 switches, and you're going to be dealing with, guess what? PPP. Frame relay is gone, so you don't even have to worry about that. So we're going to be dealing with PPP, and you might see multi-link PPP, and maybe PPP OE, which is the first half of how DSL works, and maybe configuring a dialer interface, something to that effect. So we're going to cover that. And then layer 3, 40% of both exams. So that's going to be a big chunk. And a lot of what you're going to see here, knowing all of these, IS to IS is still just in the written exam, so just knowing some of the basic topics of that. And I just recently went through an IS to IS video series, so I feel a little more confident in the technology and how to implement it and how to make it work, as well as the addressing schemes that go along with them. Layer 3 multicast, that's going to be a big portion, but understand that what you're going to see now is going to be a lot of optimizations for routing, like I mentioned with the multicast feed. Now, it does say as an industry standard continues to move migration towards IPv6, they removed the IPv6 section. As you can see right here, there used to be an IPv6 section. They've integrated it with everything. So a lot of what you're going to see is going to be dedicated, the version 4 blueprint anyway, was dedicated at IPv6. So you would have to make sure you knew Ospf V3. You had to know what RIP-NG. You had to know EIGRP for IPv6. You had to know multi-protocol BGP and the address family IPv6 and unicast and multicast and how that type of stuff works. So you take those aspects into consideration when you're going through your studies. We're going to cover those, and I'll show you some of the techniques that I'm using to cover them and how they work. Multicast has been removed as a whole and has been replaced with infrastructure services. So when you walk in and you're dealing with multicast, you're going to need to know what Igmp is. You're going to need to know what PIM is. You're going to need to know what MLD, Multicast Listener Discovery Protocol, and MSDP, which is Multicast Source Discovery Protocol, and knowing the difference between dense mode, sparse mode, and sparse dense mode, and how they all come into work, and how signaling works, and things like that. It's going to be a big topic, which it's 15% of the lab, but understand that there's more than just multicast as a service. There's DHCP, there's DNS, there's FTP, there's SCP, I can keep going. But Vpn Technologies is actually a very cool topic where they've brought in, let's see here, we brought in a standalone domain where tunneling and encryption. Tunneling is going to be getting traffic from one place to another and separating it from the global routing table. For instance, MPLS and Layer 2 and Layer 3 VPNs, as well as DMVPN and IPv6 tunneling. So you take those concepts, what was in the version 4 written in lab, and knowing what an MPLS Layer 3 VPN is. So if you're running OSPF in your core of your SP network, and you've got IBGP, then you've got MPLS, LDP, VRFs, VRF-aware routing protocols, address families and things like that are going to come into play. I just went through an MPLS video series about a month and a half ago, so still pretty fresh. A lot of this stuff I'm covering because of the fact that I know what to expect and how to deal with it. So it's cool in the respects that it is. Now this is tunneling, which is going to be logical. It's going to be making a logical point-to-point connection between two different devices, or potentially subnets, depending on how you're implementing it. Then we have encryption, which is IPsec VPNs for both the written and the lab. And you're going to have GET VPN for the written exam. GET stands for Group Encrypted Transport. So that's going to basically allow you to kind of consolidate how things are encrypted. And we'll get into that when we get into the written exam topics. But moving a little farther down here, we have infrastructure security. So, as you can see, we have the device security, which is going to be configured, making sure that control plane policing and access lists and AAA and local authentication, things like that. And then network security, which is going to be like VPNs and stuff like that. DMVPN using Ipsec with a hub. And then now one thing that they're putting in here to limit how deep the VPN section can go, or it's secure, I should say infrastructure security, is it excludes any type that relies on dynamic crypto. So PKI, public key infrastructure, which basically means that you're not going to have a branch site trying to go across a VPN tunnel to authenticate against a AAA server at the main location. So they're removing that aspect of things, so that when you're dealing with it, you're dealing with a local database. And then we have infrastructure services like network management, system management, network services, QoS, network optimization. Now it says Layer 2 QoS is only the written exam only, and then supporting the lab exam topics to focus on platform-independent concepts. Part of the reason why the V5 lab has now gone virtual, because they were finding issues with platform dependencies, to where the 3560 could support private VLANs, but the 3550s couldn't. Things like that. So, but as we go through here, things that have been removed or added to the written exam, not a lot, but you need to know what they are and how to deal with some of these guys. We do have L2 VPN LAN services. This is going to be the essentially what they call MPLS Layer 2 VPNs, or VPLS, or Virtual Private LAN services, and how you can use where MPLS L2 VPNs are a point-to-point tunnel between two branch locations. You might have a location in Egypt, you might have a location in Dubai, and you have a Layer 2 VPN, which anytime you see Layer 2, that's automatically going to imply that the service provider network has to have, from both locations, has to have a Layer 2 connectivity between both locations. So it gets kind of wacky in how things get actually implemented. Now, when you deal with VPLS, that is a multi-point Layer 2 tunnel. So, because of the fact that it uses VRFs to forward traffic, and you're dealing with VRFs in the same respect that you would be with MPLS L3 VPNs, which can be multi-point, because you can have several routers that are using VRFs and IBGP to route traffic based on source and destination IP address. It gives you a little bit of flexibility in how you actually implement things, but we'll talk about them and how they work and all that other good stuff. Some of the topics that are added to the written and lab exams is obviously going to be iOS troubleshooting tools. There's going to be embedded packet capture. We'll talk about that and how it works. It's actually kind of a cool technology. And then advanced troubleshooting methodologies, interpret packet captures, BFD, bidirectional forwarding detection, and we're going to deal with EIGRP multi-address named mode, which is going to be a way for you to work with it with VRFs, and implement and troubleshoot and optimize EIGRP and Ospf convergence and scalability. That's going to be the core of your network, right there, core of your network. DMVPN single hub, that basically means that you're going to have a dynamic multi-point VPN, and what that does is it's going to give you the scalability factor, and basically it's going to act kind of the same way Frame Relay worked, and but there's going to be some where inverse ARP was a dynamic capability for you to learn your neighbors. Well, NHRP kind of does the same thing, except for the fact of when you're dealing with DMVPN, depending on which phase you're using, 1, 2, or 3, it will determine how traffic is routed wherever it needs to go and things like that. But we'll talk about that more in detail. IPsec with pre-shared key. This is going to be pretty much the most basic way you can set up an IPsec VPN. When you see IPsec with pre-shared key, you can pretty much almost guarantee site to site. Now, you don't have to do it that way, but that's the most common thing you're going to see. Typically, if you're going to see SSL, that's going to be web VPN or remote access. IPv6 first hop security, so we'll talk about router advertisement security and neighbor discovery protection when it comes to IPv6. And then topics move from the lab to the written. Multicast for IPv6 and tunneling techniques. Describe iOS AAA and TACACS with radius. These are pretty straightforward. As soon as you implement AAA, you can create a default method list and or a custom method list if you're so inclined. And basically what this will allow you to do is you can authenticate to a TACACS or a radius server, and as long as you point out what the radius server's IP address is and the key that you're going to use for it, and then from there you can also kind of layer in .1x authentication at the port level, and then depending on how you want to work with it, you could take that down to the line card level and tell the individual port that if the device connected to the switch on a particular port doesn't have the capability of running .1x, where the network card isn't compatible or capable of it, you can tell it to it's automatically authorized. So there are some functionality capabilities that are out there that we'll talk about and how that works. Topics removed from the exam completely. Flex links, ISL, and layer 2 L2TP. What that basically was, flex links was a way for you to spanning tree was a different variation of it, and they removed that. Layer frame relay gone. It totally gone. Like not there anymore at all. Web cache configuration protocol, which was a way for you to do redirects for proxy servers for web proxying. iOS firewall and IPS. I'm actually really happy they removed this because I don't really feel like that's necessarily a routing and switching topic that really needs to be covered. If you really want to know that much, go take your CCNA security exam. It's covered there. Just my opinion. I don't think that was something that I needed to have in there. That was too much security for me. I had a really hard time grasping the concepts, and once I went through CCNA security, bang, I got it now. Write in RMON, which I'm not 100% sure what RITE stands for, but RMON is remote monitoring, which is a basic version of SNMP. Then we have RGMP, which is router group management protocol, which was basically, I believe the layer 3 IGMP. Then we have RSVP, which is resource reservation protocol, and weighted round robin and shared round robin. So those are gone. Now, when it comes to the actual delivery of how things are going to go, the way that they've done this is that basically you may have heard of the term called Web IOU, which stands for iOS on Unix. The way that they're delivering it now is they give you a web. It's going to be the same delivery as a version 4 lab, from what I understand, except for now everything's virtual. Before, when you were in the troubleshooting section, you had 30, 35 devices or whatever the case may have been, and that was your troubleshooting section. So you had all these different networks and areas to work with, and to 10 or 11 or 12 tickets or whatever you may have been given, and you would have to work through the web-based software routers, if you will. They're virtual routers. Well, what they've done is, I'm not sure if they're using Viral or if they're using IOL, which is iOS on Linux, or whatever the case may be. Whatever Cisco decided to go with, I'm glad they went this way, because the fact that it gives, you're now being truly tested on the technology and not being hindered by whatever the platform can support. So back in the day, like I said, 3550s couldn't support private VLANs. Well, I know I've seen WebIOU, Cisco Live. I've seen it at Cisco, given access to it. WebIOU, whatever the iOS image is capable of running is whatever you're going to be able to implement. So when you walk in there and you do a show private VLAN type, it's there, or show VLAN private VLAN type. The iOS image, if it's capable of running it, it's going to be able to run it. It's going to be like GNS3 in some cases. I know GNS3, I know they're working on something for GNS3. I haven't been given an update yet. But one thing that I really like about what Cisco's done is they've taken a lot of feedback from a lot of people that have taken the lab, and they've given you this option of an additional 30 minutes. This 30 minutes, I know a couple of guys recently that have taken and failed their CCIE lab. They needed an extra 5 to 10 minutes. Now, I've heard a lot of instructors, I won't name any, that have said this, but a lot of instructors that have basically have said, if you can't be done with troubleshooting within an hour and 15, hour and 20 minutes, chances are you're going to have a hard time passing the lab. Well, that's kind of I don't want to say a biased opinion, but when you've got an instructor that's got 10 or 15 years of experience versus myself, who's got 2 to 3, and I'm studying for an expert level exam, yeah, he's probably going to have a lot better chance of finishing the lab or the troubleshooting section in an hour and 15 minutes than I'm probably going to have. So you take the experience level, is going to be a big benefit on his part, and then you take that and push it over to what I'm doing. I might need 2 hours and 15 minutes. It's just that I might not be able to think as quickly on my feet as he could. I might not know the configuration quite as well as him. So that's kind of a biased opinion. I'm not going to name names because I don't want to call anybody out, but I'm liking what Cisco has done here with giving you an optional 30 minutes. And as far as I'm aware, this 30 minutes that you see right here, if you only take like 7 to 10 or 12 or 14, something like that, it's only going to deduct that much time from the configuration section. So you can have up to 5.5 hours. So what they've done is they've taken this 2 hours here, which used to be 2 hours and 6 hours. They've taken this 2 hours of troubleshooting. Let's assume you don't need 2 hours. You don't need the 2 hours. You're automatically thrown into a diagnostic section, which basically is like a packet capture. They give you an output. It's almost like you're back in a CCNP exam where you've got, or CCIE written, where you're given like definite answers, and your answer is going to be one of these 4, or whatever the case may be. I don't know how many, what the question types are going to look like or how complicated they're going to be. I've looked at a lot of packet captures, so I'm probably going to be able to figure out pretty quickly what it is, but you never know. And then you have your 6 hours of configuration. Well, I should say 5.5. I'm glad they put this in here because that's a lot of times what we do. Troubleshooting is good logically, but sometimes you need to go beyond that because you might not be able to have access to the other end of the network. So, because say for instance router 1 and router 2 are connected, you may have access to router 1 but not router 2. So it's going to be really hard to troubleshoot something one-sided, where you could go into router 2 and start doing show commands there, but you might not have access to that device. So the diagnostic section is going to give you the ability to see what R2 is spitting back and be able to make decisions based on the information you see. So that's the configuration. The diagnostic section is cool in that regard. The configuration section is going to be basically everything we've covered up to this point. It's going to be in-depth, it's going to be hardcore, and we're going to cover every topic that I can think of. And so that's the idea, and we're about halfway through, but we're going to kind of speed through this. We don't need to go through all the technical, the particulars and pertinence and all that other stuff. But as you can see, it's 120 minutes with an optional 30 minutes added to it potentially. And then we have independent incidents, and then we have access to virtual devices, first topology. Diagnostic section, there is no optional time added. It's fixed 30 minutes, independent tickets, no access to any devices, multiple sources of documentation, emails, diagrams, console logs, whatever you may need to figure out what's broke. And then we have configuration, and that's going to be interdependent, which means you might have to, obviously, layer 2 is going to have to work before layer 3 is going to work. Things like that. Access to virtual devices. So very cool in that regard. And these are going to be the device platforms that if you want to run the newest iOS images, this is what you're going to have to do. So basically what they're saying is ISR 2900 series routers running iOS 15.3. That's a pretty new iOS image. I'm having a hard time finding that iOS image to download. Realistically, if you don't have a service contract with Cisco, you're not going to get it. So I'm waiting for, right now I'm running 15.2 mainline is the most up-to-date iOS image I can find. So I'm okay with it. It does the job. 3560 is running 15.0 SE. I have my 3750. I just updated the iOS image the other day, and I'm waiting patiently to see what Cisco is going to do about. I hear that Viral and CML are slated to be released. If that's the fact, or if that's the case, bring it on. I can use the help. But that's that. So I'm going to quickly kind of glaze over the written exam topics and what we're going to cover. So the idea behind all this is going to be taking what you need to know on networking and basically researching every piece of this, figuring out what everything is. So iOS and iOS XE, we'll have to read up on them, see what the differences are. Go through step-by-step load balancing hash. I'm going to assume that has something to do with, there it is, Ceph. Polarization concepts and avoidance. Then we're going to look at microburst and how that works and what it does and all that good stuff. Asymmetric routing. I've dealt with this dozens and dozens of times. That means traffic leaves on one interface, leaves on fast 1, goes out, hits the destination, comes back in on fast 2. And you got to figure out why. Why was it routed back the other direction? So, different things you can look at. TTL, time to live. IPMTU, which is maximum transmittable unit. Maximum segment size is going to be how big of a segment you can send. PMTU, never even heard of. Packet MTU, maybe? I don't know. It's all things I had to research. But these are going to be things you need to go through and fully understand before you can actually go take the exam. Then we have starvation, latency, RTP, RTCP. I'm guessing this has something to do with QoS because it says RTP and RTCP are going to be voice protocols that you're going to see. So the real-time protocol, which is going to be used for voice over IP, and the real-time control protocol, which is going to be dealing with making sure that the call signaling to the voice server is being done correctly and you're able to forward your traffic correctly, I guess would be the best way to say it. And then we have network implementation and operation. So everything you see here is available from Cisco's website. I would download these, start using them as your guidelines as to how everything works. Layer 2 technologies. I don't have to really cover those right now because the fact of I've already done most of that through my CCNP switch exam. I covered 90% of this stuff. It's only some of the stuff at the bottoms here. Alternatives to spanning tree protocol, which I think they might be talking about Trill, which is a Cisco proprietary term, which stands for transparent interconnection of lots of links, which I think eliminates the spanning tree concept. It almost, the way that it's been explained to me in previously, was it's almost like taking port channels and bundling all of your network or your ports together. So there technically is no block port, I guess would be the best way to put it. I'm not 100% sure. Some other concepts that are going to be need to be covered. We have our Multicast, which is Internet Group Management Protocol V1, 2, and 3. Um, Snooping, Courier, Filter, Proxy, Multicast, Listener Discovery, PIM snooping, and then we're going to get into our WAN circuits and things like that, and Metro and WAN Ethernet technologies, which when they're talking about rate-based Ethernet circuits, Metro E and WAN, we're going to talk about those and how you can rate limit things and all other good stuff. I've got some experience with that in service provider networks. Layer 3 technologies, we're going to deal with, obviously, Unicast and Multicast, EUI64. Obviously, there's going to be some IPv6 thrown in here. So address types and VLSM and ARP. We're going to deal with ND, router solicitation, router advertisement, autoconfig, stateless autoconfig, temporary address, which is going to be the :/128, I believe. If you're doing any type of DHCP, that's going to be a placeholder for the source address. Global prefix configuration feature, and then we're going to have stateless autoconfig, things like that. And then we're going to go into multicast RPF, which is reverse path forwarding, and then all the PIM features. Some of the stuff is a little beyond me right now because of the fact that I haven't spent a lot of time dealing with it. But I promise we will cover it in detail and how it all works. And then we're going to have fundamental routing concepts. Do you know the difference between distance vector, link state, and path vector? Which is going to be EIGRP and RIP, OSPF and IS-to-IS, and then BGP. So we'll talk about those. All these guys are going to be covered. I'll show you a couple of, in the next video, I will show you some documents that I would recommend reading so you at least have an idea of what each one is. We're talking about loop prevention mechanisms and when it comes to route redistribution. So you should know how to do that between any protocol, no matter how it's actually brought into play. And then we'll talk about protocol authentication and how that works. Some of this stuff, through my initial studies, is only capable through the iOS 15.3 image. So, like I mentioned a couple minutes ago, I'm running 15.2 mainline, so Advanced Enterprise Services, on the 7200 series router in GNS3. So a lot of the stuff that you're going to see is going to be based on that. However, there's going to be a few things in there you're not going to be able to see because it wasn't introduced until 15.3. So we'll cover that when we get to that. Now, some of the other topics that are here when it comes to like EIGRP, over the top, point-to-point, and route reflector, some of these things are going to be 15.3 as well. They're not supported in 15.2. Not exactly sure what they're trying to do with EIGRP with this stuff, but we'll talk about that when we get to there. And then we're going to see Ospf V3, V2 and V3. Now, there's a common misconception when it comes to V3 that V3 is solely IPv6, and it's not. Ospf V3 was rewritten to support IPv6, but it also supports IPv4. So you can run address family VPN IPv4 unicast and IPv6 unicast under Ospf V3. So you can do both, and we'll talk about that when we get to it. But there's going to be quite a bit of stuff here that we're going to need to cover. And BGP obviously is going to be a big section. And then down here we have IS-to-IS, which now that I've gone through a couple videos and understand how the basic concepts of how IS-to-IS works, it's going to be a little easier. They're doing it in a single area, single topology. The way I was shown how to do it was a multi-area, which is actually really, really easy. You just have to understand the different levels and router types and interface types and how each one works and things like that. It was actually pretty easy, so I don't think I'll have too many issues with that. Now, the Vpn Technologies is mostly going to be MPLS and DMVPN, because those are tunneling, because they're using GRE and MPLS L3 tunnels. Down here at the bottom where it says encryption, you're going to be dealing with IPsec site to site and IPv6 and IPv4, which is a good way to don't. I guess it could go either way when it comes to IPv6. The reason I say that is because the fact of when you're dealing with IPv6 and IPv4, basically you're taking the IPv6 payload and dropping it inside of an IPv4 packet and shipping it across the IPv4 internet. So we'll see what exactly it is that they want us to go into detail with, and we'll go from there. And then infrastructure security, obviously AAA. That's actually really easy now to play with it a few times. It's not hard at all to deal with. It's just a matter of understanding what it is that they want you to do and the different aspects to it. Network security is going to be kind of a bigger chunk than AAA, and some of the different things you can do with that. First hop security, RA guard, ND inspection snooping, source guard. So infrastructure services, obviously, is where we get into QoS and HSRP, gateway redundancy, things like that, and then DHCP, DNS, NTP. Knowing how that all works, NAT is going to be kind of a bigger chunk. And then we have network optimization, and here we're at the bottom of our list. So optimizations and knowing how to do object tracking, which is IPSLA, and NetFlow, and knowing how to do PFR. Oh, that's we're dealing with the embedded event manager. So I've never really played with that, but it shouldn't be that hard. And then the last thing we're going to talk about is the CCIE actual lab topics. It's going to be pretty much a replication of the written, so I'm going to skim through. Most of this stuff is the same. So troubleshooting layer 2, we'll deal with the embedded packet capture. Well, like I said, most of the stuff is the same, but until we get to EIGRP, as you can see, they've gotten rid of over the top. So because they know that that's going to be and this is my guess, because of the fact that that's more of a brand new feature. Unless, like I said, unless you're running V3 or 15.3 is your operating system, you're not going to even see this capability available to you. Most people I know are running 15.1, 15.2 at the latest. So if you're running 15.3, yeah, the capability is out there, and we'll talk about how it works at the V4 at the written level. Right now, a lot of stuff you're going to see is pretty straightforward with how everything works and some of the stuff that we can work with, and we'll go into detail on this stuff as well. Ospf V2 and V3, pretty much just taking what you learned in the CCNP and taking it a few steps farther. So there is a TTL security mechanism, and then there's going to be some fast reroute and some LFA, which is loop-free alternative for multi-hop, which is basically the same thing effectively as an EIGRP feasible successor. So you're going to see how you can have a backup route, which whenever you see a fast reroute is basically what they call link and node protection, an MPLS, which allows you to calculate a route. Say if you have a diamond formation, router 1, router 2, and 3 over the top of each other in router 4, where your primary route is going to be over the top, and then your secondary backup route is going to be through the bottom. So you're able to go both directions regardless of what's going on. So in case something happens between router 3 and 4, router 2 and 4, you can automatically reroute traffic with minimal drop at the most, going around to the backup route. So BGP, nothing really changes there. There's going to be some added things in here that are going to multipath has been added. I don't see Ecmp, which is yeah, I don't see that. Multi-homing, clustering, yeah. Most of the stuff right here has already been covered. So most of the stuff I'm familiar with. Ecmp stands for Equal Cost Multipath, which allows you to utilize more than one best path per BGP. And then troubleshooting layer 3, embedded packet capture, pings, and extended options like doing a ping sweep and doing recording your route there and back. I'll show you some of the optimization things you can do. Vpn Technologies, obviously implementing L3 VPNs and extranet, which is basically allows you to route leaking. We'll talk about how that works. Dynamic GRE, which is going to help you get DMVPN set up, or a multi-point GRE, and then NHRP and DMVPN with an IPsec using pre-shared key, which is basically going to be a hub and spoke, pretty much a replacement for frame relay, effectively. And then encryption, site-to-site tunnels, and then VPN Technologies. Troubleshooting them, what exactly does it have? Not sure how far it's going to make us actually go with that. And then, obviously, network security, and then infrastructure security, and infrastructure services. So, a lot of the stuff you're going to see is reflective of the old Cisco, the version 4 blueprint, just with a couple of twists to newer iOS images and newer technologies. A lot of what has happened nowadays is last mile technologies like frame relay have been replaced with with Vpls and Metro Ethernet. So that's why they're bringing those into the route switch side of the house, because a company I used to work for, they had a frame relay in 3,500 circuits ish, and they were slowly migrating customer by customer, area by area. So geographically, if the capability was there, you would run MPLS. So you would get rid of frame relay across the ASP backbone, and so you'd still potentially connect via frame from the CE to the PE, but in most cases you were just PPP and going that route over a T1, something to that effect. So we'll talk about those in a little more detail. But that's pretty much what we're going to cover. It's going to be a lot of information. I'm going to build this. We're going to be doing kind of a all-in-one, would be kind of the best way to put it, where we'll cover the theoretical parts of it. I'll show you how to find stuff in the documentation and go that route with it. And then as we go farther into how things work, we'll get into configuration examples and draw stuff out. And if you have an idea, after this if you see something, throw it back to me. I'll lab it up, try it out, see how it works. Normally I would throw out a topology, but I'm not doing that in this video because of the fact of I don't want it to be fixed to any one particular topology. We'll do it on a per technology base because, like I said, I don't want to be tied to a particular topology. I might come up with one down the road, but understand that the way that Cisco is doing this is they're trying to get away from the platform dependencies of the lab and make it more based on whatever the operating system is capable of, and then you can go with that route. So I'm kind of doing the same thing, but when it comes down, at the end of the day, it all pretty much boils down to the same thing. You and I are both studying for the CCIE, and I'm doing everything I can to facilitate that. So I hope this has been informative for you. I'd like to thank you for viewing.